Hey guys, it's Mr. Bosher, and today we're going to talk about applying domain and range, which basically just means word problems for domain and range. Okay, so you're going to have to really pay attention for this one because I know we hate word problems, and I know that we were just going to go with graphs, and then I took them away. Okay, I also know that the assignment, or the Google Slides assignment, seems to have not worked for most people, if not everybody. Okay, so if that continues to not work, don't worry about it. If you don't get an update from me about like, hey, it works now, go ahead and do it, then just don't worry about it. Okay. The only thing I need from you is to make sure that you can tell me domain and range when I give you a graph. So hopefully the tricks that I showed you about, x values, you look left and right, and y values look up and down, are helping with finding domain and range. And as long as you can do that, then we're in a good spot. Okay, so if the assignment keeps not working, you don't hear anything from me about the assignment after today, then don't even open it. Okay, so for now, we ignore that one because I tried everything, but I cannot seem to get it to work. All right, so instead, just make sure you're comfortable. If you're not comfortable, you let me know. Right? Domain and range is a huge part of what we learn in algebra, and we're probably going to do it multiple times throughout the year, but we need to make sure that we have like a good base understanding. So if you're struggling with the graphs with domain and range, let me know. I'll try to come back and see what I can do to help. All right, but we're going to move away from graphs for a couple days and talk about word problems. Now, these are a little tough, but we try to make them easier by following some certain steps. Okay, so stick with me here. There's a few questions that we need to ask ourselves when we try to find domain and range without a graph. All right, and we only have an equation or a word problem. The first thing is now we have context, right? I have a real world problem. And if you think about it, certain numbers don't make sense in the real world. Like if I were to go and buy boxes of cereal, right? Can I really buy negative boxes of cereal? Probably not, right? There's limits to how much I can buy. So the first thing you need to ask yourself is, well, what are the highest... let's try that again. Highest and lowest values that make sense, right, in the problem. So what is the least amount of boxes of cereal that I could buy? Well, that would probably be 0. And what's the max amount I could buy? Well, that depends on the store, right? Maybe the store has 200, so I can only get to 200 as my max. Okay? And these numbers can change based on the problem, right? So because we're in the real world now, we need to really focus on, okay, well, what is my lowest and what is my highest number that makes sense, right? Sometimes negative numbers don't make sense in the real world, and sometimes they do. The second thing is, kind of piggybacking off of what I just said, is, well, what kinds of numbers make sense, right? Or what type of numbers make sense. Okay? Should I use every type of number, right? Negative and positive, decimals and fractions, that's all the real numbers, right? Any number that you can think of, is it possible to use? Most places, that's probably not true, but there are some scenarios. Should I only use integers? Those are like the whole numbers, but they can also be negative, right? So can I use negative numbers? Can I use positive numbers? And then lastly, should I only use whole numbers, right? There's all these different types of numbers that I can use, and sometimes certain problems need specific types of numbers, and we'll see some examples of that as we go. And then this is probably one of the big questions that we need to ask ourselves. Okay, the other two we can usually like understand intuitively, like kind of like by instinct, we kind of can pick those up. But this is one that kind of stumps students sometimes. And it says, should the values be written as a discrete set or continuous interval? So discrete set or continuous interval. All right. Well, we need to make sure we understand what those words mean. I've used them in the previous lessons, but I haven't really talked about them too much. So let's step away from this for a second, and let me just talk about the difference between those two so that we have a good understanding. All right? If it lets me... Oh, okay. So let's just find a blank space down here. And we're going to compare discrete Okay. Discrete sets to continuous sets. Continuous. Okay? So, a discrete set is one of the graphs that looks like this. Let's draw ourselves a little graph. Maybe not that long. Something like this. And on that graph, we just have a few points. Right? Like maybe you have a point there, coordinate point there, coordinate point there, and so on. This is discrete because it does not have an infinite amount of numbers, right? It just has a couple points. But what's something that could be discrete? Usually, that's going to be something like a number of items. So earlier, I said like, we could say like boxes of cereal is one. Cereal. We could say, I don't know, the number of basketballs I could buy. It could be the number of people that show up to an event or something, right? Because let's think about this. Oh, you know what? Before we do that, let's look at what continuous is, and then we can more compare. So a continuous graph is what we've been doing, which is more of the lines, right? So maybe we have like a close point over here, maybe we have an arrow over there, something like that. And they're the lines, okay? And that's because we can use any type of number in these. I can use halves, I can use decimals, I can use fractions. Okay, and things that are continuous are things like time, distance, and what's another one? Maybe like weight. So how do these things differ from each other, right? What makes one discrete and what makes one continuous? Well, we can tell the difference in the graphs, right? A discrete graph just has a couple points on it, and that's it. But a continuous graph is a line. So there's a lot of numbers that are on that line, right? Because I have decimals, I have fractions, and all of the numbers in between those 2 points. When we get to the discrete examples, we only have a set number of items. When you go to the store, I can buy boxes of cereal, but can I buy a half box of cereal? Or a fourth box of cereal? Or what's like a random decimal, like a 0.37 box of cereal? No, right? That doesn't make sense. That would be an example of something that's discrete. Same thing with like a basketball. How in the world would you buy a half basketball, right? A basketball is not really usable when you cut it in half, right? Or any fraction of a basketball. Same thing with people. If someone says, oh yeah, 2.5 people showed up, you're going to be like, whoa, I got questions. What's a half person? What did they do to that person, right? So those are things that are discrete, okay? Now in my examples, they're all whole numbers, but it doesn't have to be whole numbers because you could think of something like cost, or let's just say money, could be seen as discrete as well, right? Because your prices can only get as small as 1 penny, right? I can't tell someone, oh, that'll be $4 and like, or 4.376, right? I can't tell you that because how are you going to get that last little bit? I have to charge you only in pennies. It's my smallest amount, okay? So even something like money is usable where you do get decimals, but you don't get every single decimal, right? You still have a limit to how small you can go, okay? Well, continuous things are things that don't have limits, right? At least in terms of how we can describe them. If I wanted to measure time in years, I could. But if you said, no, I want something more specific, I go, okay, well, how about I measure it in months? No, I want something more specific. Okay, I could go to days. I can go to hours. I can go to minutes. I can go to seconds. I can go smaller than seconds, right? Time is always ticking. There's no way for me to say that, oh, 1 second magically jumps to the second second, right? Or 1 minute magically becomes the next minute. There's time always flowing, okay? So that would be continuous because time continues ticking no matter what, right? We don't say, oh, it's 3 o'clock, and then the clock randomly goes to 4, right? No, we have to wait for the time to pass, and then it eventually becomes 4. We don't just jump to the next thing. Whereas a box of cereal, you buy one, and then you jump up to 2, right? You don't ever hit half a box in between. You just jump straight to 2 when you grab the second one, okay? Same thing with distance. If I want to be very specific about distance, I can. I can measure something in a mile, or I can measure something in a foot, or in inches, or in centimeters, right? I can get very, very specific. And I don't magically teleport when I try to go, like, to Houston, right? I have to actually travel every little small bit of distance until I eventually get to Houston. It's continuous, right? Your drive to Houston would be continuous. And same thing with weight. If we want to, if we want to be specific about weight, we can, right? We can use tons, and like some of our problems is going to use tons. We could just use pounds. We could use ounces. But you don't magically just jump a couple pounds, right? We have pounds in between and ounces in between. Okay, so those are all things that are continuous. You could think about continuous like a spectrum, right? Something that's continuous has a lot of things in between, right? We have very, very small changes. It's a spectrum, where discrete's more like steps. I go from 1 to 2, 2 to 3, and so on, right? I just skip all the numbers in between. But continuous, I have to hit every single number in between. So hopefully that kind of makes sense to you. If that doesn't, let me know. I'll try to come up with a different way to explain it. But that's the main idea. Am I taking steps with discrete, right? And I can skip all the fractions and the decimals for the most part? Or is the thing I'm talking about going to be continuous and I'm going to have to count every number? And the reason that we care is because how we write our answers are slightly different. If you remember, discrete sets have to use the fancy brackets. And you'd have something like 2, 3, and 6 is my domain or something, right? But something that's continuous has to use an inequality. So that's what we've been used to doing recently, where maybe we get something like -5 is less than or equal to x, which is less than 4. Okay, you see how our answers are very different looking when I have something discrete and something continuous. So that's why we need to be able to tell the difference. Okay, so hopefully I cleared that up. And now we can just go through and say, okay, how do I do a word problem? Okay, now that I know the basics, or the background knowledge, how am I going to apply it for the actual problem? Well, let's go see. Let's go back to our notes. And let's see what our first problem says. It says, Remy is shopping for pears at the farmer's market. The total price of her purchase, P of x, it's just using function notation, right? We kind of talked about this a few lessons ago, can be represented by the function P of x equals 2.5x, where x is the number of pears she purchases. Remy wants to purchase at least 2 pears, but no more than 6. All right. First question we're going to ask ourselves is not even what's the type of numbers in the domain, but what is the domain? Well, we can use what we've been saying in the past couple of videos. Domain is what kind of value? Domains are x values. Okay, so if I go through, I need to just first find out, well, what does x stand for? X stands for the number of pairs. So the number of pairs is going to be my domain. If we think about the difference between discrete and continuous, we could say, well, a number of items, was that continuous or was that discrete? That's going to be discrete. Okay, so we're going to hold on to that information because for part A, we want to more know like what's our limits. Okay, it says she wants to purchase at least 2 pairs, but no more than 6. Okay, so first of all, what kinds of numbers can I buy pairs in? Can I buy them in whole numbers, right? 1, 2, 3, 4, 5. That seems reasonable. Can I buy a half pair? Maybe, probably not, right? No one's going to sell you a half pair. Can't really buy like a quarter pair or anything like that. Can I buy negative pairs? No. Then it'd be like I have to give people pairs. That doesn't make sense. So the types of numbers we're going to use, is going to be whole numbers. So we're going to start with that. But then we want to get specific, because Remy told us that she wants to purchase at least 2 pairs, but no more than 6. So I want whole numbers that are greater than 2, or sorry, can I have 2, right? I want at least 2 pairs. So do I have to be greater than 2, or can I also buy 2? Well, if I want at least 2, that means I'm also allowed to buy 2. So I'm also going to say or equal to, or equal to 2. And then it says, but no more than 6. So again, I have to ask myself, is 6 greater than 6, right? Can I buy 6 of them if I just can't buy more than 6? Well, 6 is not greater than 6, right? It's not more. 6 is not more than 6. So I am allowed to buy 6 pairs, okay? So I want numbers that are greater than or equal to 2 and less than or equal to or equal to 6. So there's the first question. Okay, what kind of numbers do we expect to use? Well, they're whole numbers. And also, what's the limits on those numbers? Well, Remy said I want to purchase at least 2 pairs, but no more than 6. So we said, well, I want numbers that are greater than or equal to 2. That gives me my at least 2, right? But I also want those numbers to be less than or equal to 6 because I don't want to go further than 6. Right? I'm allowed to hit 6, but not further than 6, because then I'd be more. All right, that's the first thing, right? Just understanding what is the domain, what's the limits on it, what kind of numbers. Well, we said we can only use whole numbers, right? And we said that we're only buying a number of pairs, and we kind of already talked about it, in that can I buy a half pair, or a quarter pair, or some decimal of a pair? That doesn't really make sense, right? You never go to a store and see, hey, do you want to buy this 0.3 of a pair? No, that doesn't make sense. So if I had to pick between a discrete set, which is the one on the left, or a inequality, the one on the right, well, which one would make more sense? Probably the discrete set, because I can't get all the decimals and the fractions that would come with the inequality. Okay? So we're just going to leave it at that. Yeah, and as for explanation, we'll just say that it's just because we have to use whole numbers, but it takes too long to write. So I'm just going to move on. We know that that's a discrete set. And then for part C, it wants us to describe how can we find the values of the range. Okay, this will be the same step in all the problems. Okay, and how we would do that. Well, first of all, it'd be nice to know what is the range, right? Range was what kind of values? Let's just remind ourselves of that. The range is y values. And if you go back to your problem, you might say, well, there's no y. So how does that help me? Remember when I taught you function notation, I said that p of x, this guy right here, is the same thing, so same thing as y, right? So whenever you see p of x, you can just replace that with y. So if you notice, I have an equation here that says y equals 2.5x, okay? And the y stood for total price. So our range is total price, and we have an equation for it, right? That p of x equals 2.5x. So how am I going to find the range values then? Well, we use the equation, right? So how are we going to use the equation? I'm going to plug in all of the numbers in my domain. Because what are all the potential purchases Remy can make? Well, she can buy 2 pairs, so I need to find out what that cost would be. She can buy 3 pairs. I need to find out what that cost would be. She can buy 4, she can buy 5, she can buy 6, and I want to find out what are all the potential costs for Remy when she buys pairs, right? If she's planning to buy anywhere between 2 to 6. So what are we going to do? And we're going to say plug in domain values into the equation p of x equals 2.5x. Or if it helps you to write the y value, you could also have said y equals right there. Okay, y equals 2.5x. For me, I'm going to use function notation because if I have to plug the numbers in and it's written in function notation, that means that I can just go to Desmos and have it do all the work for me to get my answers for the range. Okay? Because that's the final question. In part B, we got the domain. Usually, your domain is very easy to get, right? You can get it from the problem and just already get that answer. But to find the range, then we have to finally do math, okay? But in this scenario, we got a function. So I'm going to let Desmos do the math for me instead. So I'm going to go to Desmos and say, hey, I'm going to give you some values to plug in to this function. And it's going to tell me what that is. So let me get that. We need to plug in 2, 3, 4, 5, and 6. Okay. So let's see. Desmos. We had p of x is equal to 2.5x. That's just the equation they gave us on the notes, right? And then it said, hey, plug in all of the domain values because Remy's not going to buy 100 pairs. She's going to only buy any pairs from 2 to 6, right? So I say, okay, well, then I'll check what p of 2 is. So p of 2 would give me 5. Cool. Well, she also could buy 3. So p of 3 would give me 7.5 as my cost. Well, she could also buy 4. So I get 10 as my cost. Okay, well, what about 5? P of 5, 12.5. And then lastly, P of 6, 15. So when Remy goes to this farmer's market, if she plans to buy anywhere from 2, what's she buying again? Peaches? Yeah. Yeah, okay. Or no, pears. If she buys anywhere from 2 to 6 pairs, the potential cost that she will end up paying will either be $5, $7.50, $10, $12.50, or $15. So our range is those values, right? Those are the only potential costs that Remy will have to pay with the given domain. Okay? So let's go back and write that. Nope. Okay, so our range will also be in brackets because we were in brackets earlier. Okay, if your domain is in brackets, your range is in brackets. Okay, and what did we get? We got 5, we got 7.5, we got 10, I believe we had 12.5, and then we had 15. And there you go. That's a word problem. Okay, so let's just review because it was probably a lot. Okay, before we hop into the second one, let's try to understand what did we do to get our answers here. Well, first things first, you read the problem, right? Because the problem gives you context to answer questions like, well, what's my domain, right? Or like, what variable is for my domain and what does it stand for? So we said, well, X is domain, and it stood for the number of pairs, okay? And that also helps us decide if it's going to be discrete or continuous, okay? So you got to read the problem, and you say, first things first, what are my variables, and what do they mean? Well, X will be domain, and then we see, okay, well, what does X stand for? Because when we read what X stands for, we need to figure out what kind of situation are we going to use, right? Discrete or continuous. So after you figure out what each variable is for, you can look at what they stand for and say, is that a discrete thing or is it a continuous thing? Well, number of pairs is a discrete thing. So now I know I'm thinking in the world of discrete. Then I go, cool, I have my domain. I know it's discrete. How do I get my range? You always get your range from the equation, right? We have to plug it in. And you just plug in your domain values and then write your range, okay? So basically, know what your variables mean. Use that to decide if it's discrete or continuous. Plug in your domain to get your range. That's a simple way of putting it. So let's try it again. Now let's follow those steps. And let's do question 2. And then I'll do one Alex question with you to show you how it looks on there, because it looks a little bit different. All right. Ben is purchasing frozen yogurt. The total cost of his yogurt, y, can be represented as y equals 0.15x plus 1.5, where x is the total ounces of yogurt. Ben will purchase a minimum of 10 ounces and a maximum of 14 ounces of frozen yogurt. Okay? So, first things first, what's my domain? Because the first question is asking me about domain. And I say, well, domain is just x values. So we're just going to write a little reminder. X values. Cool. What does x stand for in the problem? Well, it tells me right here, x is the total ounces of yogurt. Okay, ounces. Ounces is a form of weight. And if you remember when we talked about discrete versus continuous, weight is continuous, right? It's a spectrum. You have pounds, ounces, tons, a bunch of different ways to measure weight, right? And there's a lot, you can get 10.5 pounds, or you can get 7.3 ounces, right? You have a lot of numbers that we can use to represent weight. So this is also going to be something continuous. That might be helpful later on. And then we need to say, okay, well, I know my domain is x. I'm pretty sure it's going to be continuous, but what are my limits on this problem, right? What is the lowest and what is the highest number I can have for my domain? Let me zoom out here, because it says Ben will purchase a minimum of 10 ounces and a maximum of 14 ounces. Okay? So, we know that we can use any number for ounces, right? We can use decimals, we can use fractions and all that. So to say that in a concise way, I'm going to say, well, the types of numbers is going to be all real numbers. Now you go, well, that's a lot of numbers, right? And Ben said he only wants like from 10 to 14. So I'm going to say, well, I want only the real numbers that are greater than or equal to 10, because I wanted a minimum of 10. So I'm allowed to have 10, right? 10 is just my lowest point that I'm allowed to go, but I'm allowed to equal it. And I want a maximum of 14. So, oh wait, let's put equal to 10 right here. Equal to 10. And less than or equal to 14, right? I basically want to be any number between 10 and 14 for my weight, for the number of ounces for my yogurt, okay? And again, I don't only use whole numbers, right? If you ever stepped on a scale, were you exactly at like, I don't know, like 120 pounds? No, it's usually like you're in between 2 pounds, right? There's some ounces there. Same thing here. We're going to be in between probably a whole number. It's going to be somewhere decimal. But as long as that number is between 10 and 14, we're good, right? So we're just going to say all the numbers that are in between 10 and 14. Well, thinking about that then, if I'm allowed to have decimals, which one makes more sense? The discrete set with only whole numbers, or the inequality that lets me have any number between 10 and 14? Well, because this is weight, we know that we're probably going to end up with some decimal, right? Most likely. We're allowed to have decimals with weight. Okay? So we are going to use the inequality here. All right. So there you go. You've already found your domain, right? And to be honest, this step right here is usually not really like needed. It's more like, can you get to this part, right? And this is just the thought process that goes behind it. So you don't need to write all this out when you do your work. This is just like, hey, what should you be thinking about to get to here, right? Is it discrete or continuous? And then what is the limits? Well, our limits were 10 and 14, and we said this is weight. So it makes more sense to go with the continuous option rather than the discrete option. Okay? So just as a heads up. Part A is a little overkill for when you answer questions. All right. Part C, how will you find the range? Remember from question 1, I said it's always going to be the same. You find the range by plugging in your domain values into your equation, okay? Because we said, well, range is what? It's y. And if we look up here, I have an equation that says what y is equal to, right? And just as another thing, we could say, well, what does y stand for? The total cost. So the range is going to tell me what my cost can be, right? What's my lowest cost and what's my highest cost? That's what my range is going to tell me. But how am I going to get that? I'm going to plug in, just like before, the domain values into the equation, which in this case is y equals 0.15x plus 1.5. All right? Now, remember that we have an inequality. So technically I have 10, 10.1, 10.2, 10.5, all these decimals. Are you really going to sit there and plug in all of the decimals to the equation? Absolutely not. That's too much work. What you're going to do instead is you're only going to plug in the two numbers that are your limits, your lowest and your highest. You're going to plug in 10 and you're going to plug in 14. That's all. All right? So let's do that. You can do this by hand or you can use Desmos. I'm going to use Desmos. That seems easier to me. So let me just double check what our equation is. 0.15x plus 1.5, and I want to use 10 and 14. Okay, so I'm going to go and find my Desmos. We have 0.15x plus 1.5. Okay, well, I want x to first be 10, so I'm going to say replace that x with 10, and I get 3. And then if I do it again, but replace x with, I believe we used 14, I'm going to have 3.6. So, when Ben buys his, what did he get? Frozen yogurt? Yeah, when Ben buys his frozen yogurt, we know that his cost is going to be between 3 and 3.6, or $3 and $3.60. So how do I write that? Well, it's range. So I use y values. I put my inequality symbols. And I say, well, what was my lowest cost? It was $3 from my answers that I got. And my higher cost was $3.60. And that's how you find your range. Okay? So basically, you find your domain by reading the problem. You take your domain and plug it in. Okay? Because when you plug it into the equation, you get your range. And that's the basic follow through, right? Again, part A is a little bit overkill, just to show you sort of like the thought process on how do I know if the domain is discrete or continuous and like what is the limits. Okay, but A is a little bit overkill. You don't need to write all that. All right. So how does this work for your end? How does this work on the ALEKS assignment? It's very, very similar, but there's one part that worries me and how you guys will react to it. So I'm going to talk about that, okay? So let's move on to that. And let's see, yeah, perfect. Okay, so let's just read through this. And let's see if we notice what's different about this compared to our examples. It says, a construction crew is lengthening a road. Let L be the total length of the road in miles. Let D be the number of days the crew has worked. Suppose that L equals 2D plus 300 gives L as a function of D. Don't worry about that, gives L as a function of D. It's basically saying it gives you an equation, right? All right, and our equation is L equals 2D plus 300. That's all you need to care about. Then it says the crew can work for at most 90 days. And then if I look at the problem, it wants me to determine what is my domain in the problem, if it's the length of the road or the number of days. And then the other has to be the range, right? And then we're going to end up choosing a set of values once we get to the problem here. This is just a screenshot, so I can't really click on them. But I'll show you what it looks like once we go to the ALEKS website, okay? But the main thing I want to talk about is there's no x and there's no y. So a question that should be easy with the domain and range of, hey, like what does it stand for? Is it the length of the road or is it the number of days? That'd be really easy if they used x and y, right? But they didn't. So we're going to have to be a little bit more creative in how we determine that. The good news is it's not that hard, okay? So let's go back to our examples here and see if we notice anything. Look at this equation right there. Let's imagine, because remember, p of x is the same thing as y. So let's imagine it says y equals 2.5x. Let's write that a little bit nicer. 2.5x. Do you notice how the x, or the domain, right? X is for domain, has a number next to it, but the range, or the y value, is completely by itself? Let's see if that happens on the other problem. I have my equation right here. Do you see how the x is on the side with all the numbers, but the y is completely by itself? That's because the domain is always going to be the variable that's surrounded by other numbers. Okay? And the range is going to be the variable that's by itself. Okay? So the range is by itself, where the domain is surrounded by numbers. That's going to be the trick you use for your ALEKS assignment, okay? So if I go back to the ALEKS assignment, I see, well, I have two variables in that equation. One of them is surrounded by numbers, d, right? Where the other is completely by itself. So the one by itself will be my range, and the one surrounded by numbers will be my domain. Cool? That's the main thing that I was worried about when I saw this assignment. I was like, ooh, it doesn't use x and y. We might have trouble in knowing what's domain and range. So if we continue here, I say, well, D is domain. What does D stand for? If I look in the problem, it says let D be the number of days. So I go, well, I just found out D is domain, right? Because it was with all the numbers. And it just tells me that D is the number of days. So my domain is going to refer to the number of days that the crew has worked. For the range, it's going to be L, right? And L is the length of the road. So that is awesome because now one